Hello everyone, my name is Woei-Chyi Chang and I am a PhD candidate in civil engineering at Purdue University. I'm happy to present my human factor research with collaboration with Professor Yu and Professor Hasanzadeh. The topic of this research is related to distraction and situational awareness during human-drone interaction. At the beginning, I would like to provide an overview of the current construction industry. As there are lots of complicated and demanding tasks ongoing at the same time, workers not only need to work in teams, but also have high-performance teams. More importantly, safety must be ensured throughout the construction projects. Construction is one of the most safety-critical industry because of different types of hazards on site. I listed 4 examples of hazards here: physical hazard, fire hazard, electrical hazard, and struck-by hazards. Therefore, workers have to pay attention to hazard and surrounding environments to maintain situational awareness and ensure safety. Construction is changing as more robotic and autonomous technologies are introduced to construction sites. Among them, the application of drones within construction have been highlighted. Meanwhile, workers will be still in the loop to interact with drones and other autonomous technologies in the near future. Because robots are still not perfect, they might potentially cause safety concerns for workers, such as collision. Especially, drones are flying around the environments, therefore, workers also need to pay attention to drones during interaction to ensure safety. However, there are 2 similar but different concepts regarding human attention have been mentioned in human-drone interaction literature. There are situational awareness and distraction. Considering drone as a hazard, workers need to identify it, comprehend its risk, and project its future states. Therefore, attention is needed in situational awareness. On the other hand, considering drone as a distractor, workers might allocate their attention from primary tasks to drones. Although both concepts are related to attention, situational awareness is positive but distraction is negative. It is challenging to tell difference between them only based on human attention. Therefore, this study aims to distinguish between situational awareness and distraction during human-drone interaction through a high-realism mixed reality environment by categorizing different risk levels of interaction and including multidimensional human responses. A mixed reality bricklaying experiment was developed in Unity to conduct this user study. I would like to provide a video showing an overview of the experiment. As you can see, a participant was performing the bricklaying task. Meanwhile, there were drones coming to interact with him. This study used HTC Vive as the VR device to collect eye tracking data and biomedical sensor to collect physiological data. To enhance the sense of presence, this experiment included environmental modalities such as construction noises and winds, and a physical guardrail to provide haptic feedback. Literature has summarized different levels of interaction between drones and humans. Each level has its unique interactive behaviors and corresponding risk during interaction, which might affect the evaluation of situational awareness and distraction. Therefore, this study selected a baseline level plus 2 other common levels. Specifically, the baseline level means that there is no interaction between workers and drones, indicating a low risk level. An inspection drone was designed to represent an interaction at coexistence level, which means that the drone shares a workspace with workers without direct communication. Collaboration level was manipulated by a delivery drone. The drone and workers shared not only a workspace but also goals and objects. Coexistence and collaboration refer to medium and high risk levels of interaction, respectively. To increase the sense of interaction, drone sounds and spinning blades are involved in the environment. Participants were asked to finish a 7-minute bricklaying experiment where they will interact with each drone once, followed by completing a pulse survey. 4 performance metrics were considered in this study. Participants' eye-tracking data was collected during experiment, and 2 metrics, dwell time and run count, were calculated to understand their visual attention, which is involved in both situational awareness and distraction. Participants' productivity was also collected by recording how many blocks they finish per second during different interaction levels. Literature has suggested decreased productivity in distraction, while it might be neutral in situational awareness. In the post survey, participants were asked to report their sense of presence from 2 perspectives: place illusion and plausibility illusion. Meanwhile, they needed to recall the frequency of allocating attention to drones and have reflection on it. As maintaining situational awareness is an intentional behavior, reflection score should be higher than recall score, which might be opposite in distraction. Let's move to the results section. As you can see from the figure, majority of participants reported positive sense of presence in the MR environment, which can ensure that participants' naturalistic behaviors were collected during experiment. Regarding attentional allocation, the figures shows participants' dwell time and run counts on drones across interaction levels. Compared to no interaction level, they allocated significantly higher attention at coexistence and collaboration levels. The results again show that it is difficult to distinguish between situational awareness and distraction merely based on attention. Regarding productivity, as you can see from the figure, participants had significantly lower productivity rate at coexistence and collaboration. Based on literature, a decrease in productivity shows that humans might experience distraction. Even so, further evidence is still needed to finalize the evaluation. Human intention can provide important insights. The figure shows an overview of whether participants intentionally pay attention to drones or not. The reflection score is lower than the recall score at coexistence. It means that participants perceive their attention as unnecessary and unintentional, indicating a potential of distraction. On the other hand, the reflection score is higher than the recall score at collaboration, showing their intention to pay attention to the drones. It is considered situational awareness in this case. The finding shows that drone sound and spinning blades are effective to enhance users' sense of interaction with drones. Also, humans tend to experience distraction during coexistence and maintain situational awareness of drones during collaboration. A clear distinction between distraction and situational awareness can be applied to other safety-critical domains, such as driving and aviation. For driving, it's very important to discuss the interaction between drivers and autonomous vehicles in the future. Regarding aviation, discussing the interaction between pilots and cockpit is also very important. This study contributed to supporting the robustness of the MR environment in simulating human-drone interaction and including multi-dimensional human metrics to comprehensively distinguish between situational awareness and distraction across different interaction levels. Meanwhile, future studies can consider diverse groups of participants in user study and include different physiological responses to make the discussion more comprehensive. At the end of my presentation, I would like to appreciate the support from the National Science Foundation. If you are interested in relevant research, please feel free to read my other papers that you can get from the QR codes or reach out to me. Thanks for your time and attention.